Okay, hello everyone. My name is Jussi Haapelo. I'm the project coordinator of 6GXR, and welcome to the first open call information webinar. And yeah, can you go to the next slide? So about the agenda of today, so we're going to briefly introduce the project, and then Flavia will, Eleni will provide the code presentation details. Then we have a description of the research infrastructures we have in the project. And afterwards, the topics that we are especially interested in this first open call. And finally, there will be a chance for half an hour Q&A session for more detailed questions and comments. So next slide, please. So firstly, I'm going to introduce the project a bit. So we are a project of 15 partners spanning for 3 years. It started at the beginning of this year, will end at the end of 2025. 15 partners from various countries, 8 different countries around the Europe and associated countries. And essentially we have 3 major objectives for this project. So this is a Stream C project, so it's an infrastructure project, and hence one of our, let's say, first key objectives is to build a multi-site research infrastructure that can provide a validation platform for multiple 4G and 6G use cases by developing enablers to run those use cases. And we're planning to also go beyond 5G and towards 6G technology. And in addition to that, there will be trial management to govern the entire set of infrastructure, as well as abstraction tools for some other services. So as a part of that, we will validate multi-access edge computing scenarios. So we will go through the entire cloud continuum on where to provision the services based on the requirements of particular services, especially XR. And the third key objective is to demonstrate and validate the performance of innovative 6G applications, especially focusing towards XR, VR, meaning holographics, 3D digital twin, etc. So we have a number of objectives in the project. Firstly, there are 4 research infrastructures in the project, so what we call South Node and North Node. So the South Node consists of 2 different infrastructures, which is 5G Tonic in Barcelona, and then in Madrid, and 5G Barcelona research infrastructure in Barcelona. The North Node, it consists of Oulu, Finland. There is University of Oulu 5G test network infrastructure, and as well as VTT 5G test network infrastructure. So if I go briefly onto the objectives of our project, so they are quite multitude. The objective 1 focuses on networking and computing enablers, which is one of the key topics of this open call. The second objective focuses on XR enablers, which is also another very relevant topic to this open call. Then there is another which is objective 3, and we focus on run enablers. The project addresses all of the different 3 approaches, so the 3GPP avenue, also the Open Run avenue, as well as addressing disruptive technologies, especially on the 140 gigahertz side. Then there we have another objective which focuses on energy measurement system and validation. So in the project we are creating an energy measurement framework to be able to characterize the energy consumption of the entire end-to-end communication systems, along with the renewable energy generation, like energy weather forecasting, and going towards balancing the amount of energy that can be generated renewably towards and matching that with the consumption of the entire system. So going towards essentially zero energy solutions. Objective 5, sorry, that was objective 5. Then we have objective 6, which focuses on the use case validations, and that's basically will be more towards OpenCall 3. And then we have, of course, objectives matching these cascading funding actions, which this seminar is all about. So the topics, major topics for this open call are firstly, networking and computing enablers. Secondly, XR enablers. Third is run enablers. And then the fourth one is the sustainability enablers for local green energy, controlling energy resources, charging, discharging, energy measurement, optimization, and solutions. So I guess that's a brief introduction. We can advance.
Thanks, Jussi. Thanks a lot. I'll be taking the floor now. This is Eleni Pehlimanidou from Artel Innovate, managing the open call process in the 6GXR project. Here we will go through the main components of the call requirements. So first and foremost, of course, it's the submission deadline. The call has been open since Monday on the 25th of September and will close on the 27th of November at 5 o'clock at Brussels time. This is the final submission deadline. Before that, as we advise in the information document, we are requesting applicants to submit a draft proposal, so specific parts of the proposal template, in order to perform a feasibility check, to get feedback basically by the project, whether the idea of that you're proposing can be implemented based on the infrastructures and the possibilities that are offered in the project. And for this, the deadline is 31st of October, and we strongly advise everyone, of course, because the feasibility check will be performed either way, but we just don't want you, of course, to submit a full proposal that cannot be applied at the end. Here a note, of course, that this will not be an evaluation, but a feedback on the feasibility, on whether it's realistic, basically, to perform the experiment in the infrastructures. After that, main date would be in December, where it's scheduled to perform the evaluation, the independent evaluation of the projects, of the proposals that we will receive. And then to notify the applicants before the end of the year, and starting the experiment in January with a 5 or 6 months duration until June 2024. Next slide, please. In terms of who this call is targeting, of course, in terms of eligibility, all organizations that can receive funding from the Horizon Europe program can participate. I will speak specifically on the eligibility criteria in the next slide, but here are the, let's say, targeted participants that we're looking for in this call, which are SMEs, in general, companies in the industry, research and scientific organizations, and universities in the academia world. But of course, to keep in mind that these are, let's say, the targeted participants. But of course, those who are eligible for Horizon Europe can participate in case they're not included in this category. Next slide, please. So the eligibility criteria Here, the applicant needs to be a legal entity based in an EU member state, and here you have the list of member states and also associated country associated to Horizon Europe. And for the full list, you can access the link when the presentation will be online on the website. Also, this call is addressing single parties, so consortia are not eligible to apply. You need to be a single party, a single organization proposing the project idea. Also not connected to any of the partners in the 6GXR project in any way, in order to avoid conflict of interest, of course. And of course, the type of activity that you're proposing in terms of cost, so personnel, travel, and overhead or indirect cost, 25% of the direct costs, should be described in the proposal that you will be submitting. Your proposal needs to be in the English language, and also submitted only through the website submission tool that is available on the project's website, the online form, and also uploading the necessary documentation. We will not be accepting proposals through any other venue. And the deadline, of course, to respect the deadline, the time and the date, the 27th of November at 5 o'clock. And the proposal needs to be also compliant with the GDPR in terms of the personal data that is included in the proposal. Next slide, please. In terms of the budget, so each project is entitled, they can request up to 60,000 euros. And the payment is scheduled to happen at the end of the project based on the approval of the report and the deliverables that have been agreed by the consortium. So in this round of the call, in general, in the project, we are expecting 3 waves of open calls. In this first one, we are expecting to fund 8 projects with a total funding of 480,000 euros for the duration of 5-6 months. Now, this means that basically at the end, the final report, there is a template in the information document that you will find, this which is subject to changes, of course, but to give you an idea of what is expected. And based on the assessment by the mentors and also by the consortium, the payment can be released after the approval. Next slide, please. In terms of the submission, how do you submit your proposal? As I mentioned before, on the website of the project, there is the online form that needs to be completed, and also upload the necessary documents. These are 2 documents for the proposal. You can use the proposal template and fill it in. There are guidelines for specific section there. And at the declaration, sign and date, and put the date on the declaration of honor, which states that you do not have any conflict of interest and that you are also prepared as an organization to receive the funding. And also only through this can be done only through the website for both phases, so also for the feasibility check and the final submission. Here it's important to note that when you submit your proposal for the feasibility check, then you need to resubmit it in order to have a final submission, and there is the option to indicate for which phase you are submitting the proposal. But if you submit it for the feasibility check and you do not submit it for the final submission, we cannot consider it eligible and evaluate the proposal after the deadline. So please make sure to submit it also for the final submission after the feasibility check. There is also frequently asked questions. Here it will be updated based on the questions that we will receive throughout these 2 months. And of course, you can address if the information that you're looking for is not found in the documents in the website. Please reach us at opencalls@6g-xr.eu. This will be available afterwards also in the questions. Next slide, please. And as soon as the deadline is over, we will go through the evaluation process, which is also described in the information document. Here you see the evaluation criteria that will be where you will be receiving scores with a minimum score to reach 30 points, and the maximum is set at 70. But basically what we're looking for here is about the clarity of what you're proposing and sound and methodology. Also the ambition to go beyond the state of the art. This is also very important. In terms of the impact, of course, we're looking for technologies and domains that fit within the scope of the project and its objectives. We're looking also for projects that can be replicated and solutions that can be replicated, and contribution to the standardization in terms of the solutions that are proposed. We're also looking, and we will be checking the team's capacity, the expertise, the research domains that are targeted by the specific team. There is the option also, of course, to attach the CVs. It's actually required. And the value for money, how efficiently you're proposing to conduct the experiment. We're also prioritizing SMEs based on the requirements of the work program. We're looking at 50% of the proposals to be targeting SMEs. And the gender dimension is also important in the team and in how it is addressed in the project in general. And the maturity of the organization, but also the solution, so the development that you are targeting. How much advanced, at which stage, basically, it is. And in terms of the evaluation process, so once the deadline is over, we will be conducting an independent evaluation with experts who are external to the project. With each expert, so each proposal will be evaluated by 2 different experts and followed by a consensus meeting and a final ranking and approval by the Open Calls Steering Committee, which is composed by the project consortium partners. Also important to mention here that we're looking, so organizations, of course, can apply to more, can propose more than one proposal, although they can be awarded only one project. And in that case, if in the case where both, let's say we have a situation where there are 2 projects very high in the ranking from the same organizations, we might be able to give to the proposer the option to choose which one. But that's in the extraordinary case of having actually 2 projects at the very same level from the same organization. But you're of course free to apply to more than one topic. And after the evaluation, as described in the party agreement, which is also available online, but subject to changes, of course, until the end of the call. We will be conducting a legal and financial check, signing the agreement, and of course, as soon as it's signed, we can implement with the guidance by mentors who are the consortium partners in the project and will be guiding you through based on the infrastructure and the topic that you have chosen. Next slide, please. Yes, so now we will be going to the research infrastructures with Antti Pawan from Oulu. Antti, please.
Yes. All right, so then we have the first slide. Okay, so my name is Antti Pauno. I'm from the University of Oulu, from here in Finland. And I'll give you a brief introduction about the 5GT and the test network that we have here at the university. So first of all, we call ourselves a micro-operator, as we have our own PLM, and then we have also the SIM cards that are specific for us. Currently, we offer in 5G the non-standalone and then also the standalone solutions. So the transition from the 4G using the EPC in the NS area and then the pure 5G core in the standalone version. We have 2, 4, and 6 beam solutions tested, and currently we are using 6 beam beamforming in the SA area, so on the north side of the university. We have also 4G with various frequencies, and I'll show you the frequencies in the later slides. We offer also cellular IoT at the campus area, where we have more than 400 sensors active currently, both in the campus area and then in the botanical garden that is on the north side of the campus. In this map on the right side, it's this green area, and then a bit east from right from that green area where we have the greenhouses. Then we also offer the energy consumption and production measurement environment with solar panels and then measuring the energy consumption in the RAN. We have done several integrations to with different verticals. And as we are part of the 6G flagship that is based here in Oulu, we also have a roadmap towards the 6G TN. So how we evolve the 5G TN to be 6G TN in the coming years. And then we'll have the next slide. So this is a graphical presentation of the network, how it looks like. So on the left side, we have the UE devices, so from the drones to VR glasses, laptops, phones, different kind of 5G routers, Wi-Fi routers, cameras connected to the 5G and AR glasses, and so on and so on. That are connected then to our 5G, 4G, 4 and 5G indoor, or then we have also, what's not visible in this picture, we have the N78 indoor license or the frequency license. And the basebands are naturally connected to the antenna, so I say, the radio parts. On the middle, we have our routers that span from 10 gigs on the outer rims of the network and 100 gigabits in the center of the network. So in the heart, connected to the core. So that functions at 100 gigabits. We have the Open 5G core, where we have the UPF, CPF. We have the edge processing environment with virtual machines and virtual network functions. We have a connection to the university internal network through a firewall, as we have also to public internet. So internet access is available through our network. And then we'll have the last slide. So this then gives a bit more detailed information about the features that we have. So the frequency licenses we have are from band 28, 147 in the 4G region, and then we have the N78 and plus the N77 that I mentioned earlier for the 5G, plus then we are functioning at the 24, 26 gigahertz in the millimeter wave area where we already have radio and baseband integrated into the system. We have 2 band 28 macros with narrowband IoT and Cat-M, 2 band 7 macros, 1 band 40 macro with the LT on DDD, and then the V7 is FDD. We have 20 pico base stations on air, then and several available for other research objectives that are in the storage now, but they can be immediately taken into use if someone has a specific need for a test that is not done with our regular pico base stations. Then 2 5G new radios, NSA, NSA. Then we have 3 5G remote radio heads inside the university campus area in NSA mode. We have several hundred SIM cards available. We are using a few different core options. So there is a EPC for the 4G and 5G NSA. We do have an open EPC, Kumuko EPC, and then the open 5G C that is used in the SA region. We have a Bluetooth-based indoor positioning system with several beacons, LoRa network with a couple of thousand sensors. Several edge servers are available. We have 36 5G remote radio heads available for use, and then a millimeter wave base station. We have several tens of different kinds of UEs, and then test software like Kaitatekko keys are more available. I've spent now the time that I was given, so I think we can switch to ETT.
Yes, thanks, Antti. So my name is Jarno Pinola from VTT, located here in Oulu as well, adjacent to the University of Oulu campus. And I shortly summarize the, let's say, the complementary assets that we have available for the experiments at the VTT premises. So we have several on a similar approach as the university here in Oulu, as we are operators to the network that we are running. So we are fully in control of the whole infrastructure where we are doing the experiments. We have, in a similar way, 5G, NSA, SA, 4G, Wi-Fi connectivity. We also have some satellite link options available if required. Those are not fully integrated all the time into the test network itself, but they are available if needed. Similar set of frequencies for different purposes, ranging from the low 450 megahertz frequency bands used for the IoT connectivity, cellular IoT connectivity, up to the millimeter wave bands. Depending on the needs for the experiments, we can choose the best options from the options that we have. Both indoor and outdoor coverage available for experiments. Carrier grade and open source core network options depending on the needs of the experiment. We have commercial UEs, CPEs for testing. We also have a UE emulator that we can use to generate more load into the network if some of the use cases or experiments require that. We have at the VTT premises capacity for MEC and edge processing capacity, and also server and storage capacity for the applications that are used in the experiments. Connectivity in Finland and towards Europe is also available through CHANT if needed, and a similar way as with the university. Renewable energy sources and accurate power metering for the network here that we are running are available. Next slide, please. Okay, here are similar kind of more details on the key assets. I will not go through them. Maybe a couple of things from the emulated UEs or from the UE emulator side compared to the physical user equipment that we have here at the moment. We can scale up the experiments with the emulator as shown with the numbers here, and some additional details on the edge processing stuff. But these are available then after the webinar on the website, so you can go through the numbers if you are interested on those. But those are the main, let's say, complementary assets here in the North Node at the VTT. premises. So I think we can move on to the South Node introduction. Thanks.
Thank you
Thank
very much.
you.
This is José Soriano from Capgemini Engineering. The main relevant aspect of the South Node is that this is comprising two separated but integrated infrastructure or laboratories. One is the 5G Barcelona, which is in Barcelona, and the 520, which is in the Madrid region in Leganés. And those are going to be integrated and are connected. They are going to be offered as two edge locations where edge orchestrator MEC capabilities are going to be available, and where the experimenter will have a pre-configured slice and a local breakout connectivity. On top of these edge cloud capabilities and network, there are going to be a network as a service sort of function following which are right now the state-of-the-art standards like GSMA, Camera API, etc. And there will be a separated radio access network at both nodes, which are going to be integrated with the same core that's going to be on the 520, it's a 5G core SA, and there is a path, a roadmap to evolve all the radio and core with the network enablers that are going to be identified as key aspects of the 6G. Configuration-wise, they're going to be available, of course, terminal, etc. And configuration-wise, we are working through this NAS exposure, of course, to be able to differentiate and to select and to modify on real time some of the parameters like the QoS parameters, the offloading of the applications within this edge cloud or sites. And in terms of capacity, we are providing enough capacity to expand to different and multiple simultaneous a compute node in these edge facilities, which are going to be empowered with different GPUs options in order to be able to drive different rendering and different artificial intelligence solution that the companies answering the open course may need. And that's all from my side. So if you can move to the next section.
Thanks, Jose. Now we will start with the topics presentation based on speakers. So speakers will be covering most of them more than one topic, starting with Antti Pavanne from University of Oulu. Antti, the floor is yours.
Okay, thank you. So if you switch to the first slide. So I'll cover three areas. One is the automated IP network measurement system. Then we have the 3D digital twin, and then the RAN slicing. I'll start with the automated IP network system here. And I think you all know that testing in any test platform is an important part of the offering there, and also it's needed here for our pretty much daily operations in the 5G TN, and also the researchers that are using the network and the companies utilize the possibilities we have for testing. So the test cases, they vary a lot between different kind of should I say, targets or environments or tests that are executed here. And as such, they require a lot of manual work. When we are defining the testing, we are building the test environment and then operating the tests. So it means that we are tying resources and time to all of the different kind of test activities that we have here. And as such, we often repeat the same procedures for each of the tests that would be automated. So in one of our previous EU projects, we developed an automated IP network test system, and that is based on Kaitotech COSIM, quality of service test software, also as a platform. The system is operational for the purpose that it was meant to, but it's not complete and it's not covering the whole 5G TN, not to take into account, of course, the 6G-XR environment that is being now planned and then implemented. So in this open call item, the target what we have is that we could then enhance the existing system what we have here to be a more professional test system, and to go from this project-specific implementation into a network, or should I say test network-wide automated system, where we could extend the automation beyond what we currently have to include all the network functions and nodes, meaning the base stations, compute nodes, edge servers, including all of the energy measurement system that we already have and that we are further developing into 6G-XR. And so what it would mean is that there would be from what comes to technology, there is a slice template that we get, and that includes the KPI information or the measurement parameters that we should measure and then deliver to the orchestration layer. So based on that, we should initiate the tests, based on the needs, then run the tests. We should store the data into the data storage that we already have here as a COSIM database. And then, of course, ending the resources. The system should be defined, then also documented, integrated, and verified in the real environment. There should be an instruction or user manual, whatever way we call it, that then could be used by the internal staff here at the university that is utilizing the 5GTN, or then remote research or testing that is done, or then also visiting researchers outside our own organization. If there are license costs for hardware and software, that is then handled by us in the 5GTN, that is not included in the open item 60K kilo euros. So Eleni, I think we can move to the next one. This was about 4 minutes as target. So the next open item I'm presenting is the FabLab Digital Twin environment. So we have a use case called 3D Digital Twin here in the North Node, where the Oulu FabLab is needed. So the use case is such that we have two persons, a remote instructor and remote user, both wearing VR glasses that connect wirelessly to a digital twin of the FabLab. In that digital environment, the remote user is presenting a 3D object for review, and if the remote instructor or the instructor from the FabLab approves it, then the object is printed in a real 3D print. So we are talking about a FabLab, actual real-world FabLab that is digitized, moved into a digital environment where we have connection to 5GTN so that we can wirelessly connect to this environment using VR headset, and then using avatars in the digital environment, we can review the 3D object and then connect the digital twin world into the real FabLab and then print the object in a real 3D printer and then deliver the printed object to the remote user. So what we would like to do here and what is the gap is that there should be a digital twin of the old FabLab. The FabLab and then the relevant objects that needs to be separately scanned should be then 3D scanned, and we have a 3D scanner here available for that kind of scanning, so it's ready made and it can scan well human-sized objects. Then the digital twin environment should run in a game engine like, for example, Unity, and we are offering the 5G network edge server for the Unity or whatever game engine that is then used. There needs to be a connection from the digital twin environment towards the 5GTN, the 3D printer, Wi-Fi, etc., different devices. The environment should be integrated, tested, and it should be ready for use at the end of the open item. Then Eleni, I think we can move to the next. page. Here we have a picture about the environment as we've described it. So on top, we have the digital twin environment that is connected through the 5G and wireless connectivity to the remote user, but also if the instructor is remote, then using the same path for the remote instructor. We have the Windows PC. We have a 3D model in the digital twin, and the Windows PC 3D CAD software and 3D model files are connected to the 3D printer. Through the 5G wireless, we have the digital twin 3D printer connected to the FabLab real world environment, where we have, for example, camera inside the 3D printer feeding then the printing process. Video stream into the digital twin environment where the remote user and the instructor can then see what is the progress. Then on the right side, we have Wi-Fi TSN. So we have a TSN network in the collaborative robot that we are controlling inside the FabLab and real world environment. So it's part of the connectivity, but in this time the connectivity is through Wi-Fi, not the 5G. So in essence, we would like to create a digital twin environment of the FabLab here on the bottom of the screen, and then connect that to the real world FabLab, and then also to the remote user and remote instructor through 5G. And then if we would go to the last item I present in the next slide. So the third one I have here to present is the end-to-end slicing with RAN resource share. So in 6GXR, 5G slicing is an integral part of the system that we develop. So it spans through the whole network, both in south, but also in the north node. So in our environment, we need to create a customizable and isolated virtual network segments in slices. So from the 5G network as slices within a single physical network. So we are slicing the 5G network into virtual network segments that have their own resources throughout the network end to end. And as such, it also then includes also the radio and the baseband parts. So the area in this open call item is then to develop the RAN resource sharing as part of the end-to-end slicing that we need to introduce, and we will introduce into 6GXR. So the target is that we'll allocate the RAN resources in a efficient way, utilizing all the resources or the radio resources that we have available, but also in a dynamic way so that we can change the allocation on the fly here in the north node. We currently have two systems that could be used. We are currently leaning towards the first one, where we have the Open 5GS core. We have the OAI RAN software connected to a N310 USRP radio. The second option, also viable and possible, is then the Open 5GS with the SRS RAN software, not the OAI RAN, and then using also the USRP N310 radio. The band that we would use here is the N77 at around 4 GHz with 100 MHz bandwidth for the radio. And I think that concludes my part here, Eleni.
Thank you, Antti. Thanks a lot. We'll move right away to Cristina Santana from Telefonica with the topic 2.
Yes. Hi to everybody. This is Cristina Santana. I'm working in Global CTO in Telefonica, leading the technical leader of the Edge project, and I'm also chair of GSMA operator platform API groups and the Edge subgroup in Camera. So, well, I would like to present to you this Edge Discovery API. currently, the Edge platform to be deployed in the project doesn't have an open source Edge Discovery API implementation to be able to provide to the upper layers. What is doing this Edge selection API is list the available edges considering the topological situation. So which we think is the gaps and the goals. The gap is that we think is needed an Edge Discovery API that consider the topological situation of the user in the network to detect in which UPF network node the user is attached to, is connected to. And that solution must be developed according to the open source principles. The idea is to use Fivetonic Lab, as Jose Soriano explained before. And the goal is to create a development of this open source code implementation of the Camera Edge Discovery API that you can find in the link that is in the slide. This API is connected to the NEF to be able to request which is the UPF where the UE is attached, and depending of this UPF, it's has the possibility of selected which is the optimal edge for that. So if you link in the GitHub of the Camera project, you can find the definition of this API, use cases, some test definition. So there are all the information in that link. Please, if anybody cannot access, well, let me know or Eleni, and we can try to fix it, right? Which is the expected feedback. As in the previous explanation, define, documented, and developed an open source code based on the Camera Edge Discovery API definition that can be even contributed to the community and can expose, of course, northbound the API and connect it with the NEF southbound. We will need also documentation and guides, code, and an integration guide to be able to integrate this software to the current telco edge platform of the project, of this 6G XR project. I think that is all from my side, Eleni. Thank you very much.
Thank you. Thanks a lot. We move on to Matus Kirchmeier from Asuko for the topic 3.
Hi, everyone. Hi, Eleni.
Hi.
Can you hear me now?
Yes, yes.
Perfect. So for this holographics API, I'm here with Maria from Matsuko, CEO, and we are developing the holographic presence app, as you know, using just one single camera. And what we see is that the holograms, when we talk about holograms, here are the holograms of the people, can be used in many different use cases. So in our case, we are within the project doing just a simple communication app. So that's how holograms can talk to each other. But all the other use cases, for example, when you want to have a hologram with, and I'm going to give these examples at the end, with some environments, with some 3D content embedded to some platforms, all these kind of things can be possible. And we want to then work on this. We want to see this open call being enabling this. So in many use cases, we can embed the standalone component of the hologram. As a standalone component, we mean that it's a component that can be used in other developer tools, integrated in other developer environments. And this is, of course, the form can be various, but the fact that it's standalone, it enables easy integration with other third-party applications. So I think what is good to explain, like similarly in 2D video, so let's make a metaphor what already exists in the 2D video. So if you have a 2D video of a person, you can embed it, for example, on a web page or an application. And that's a very classical use of 2D videos and how it can be embedded in other third-party applications. Same can be possible with hologram. So what we want with this open call is to be able to hologram to be embedded in other platforms or applications. So, for example, the interactions with this component would be to spawn the hologram. It could be done, of course, programmatically by a script or activated via a user interface. In this case, it could be a button, or it could be just a link, or a button which is linked with a link. A good example is YouTube URL links, which you just click, and there's a YouTube video that can pop up. For example, good examples are like chat platforms like Messenger or any other, Twitter, X, and all these. So you can have a YouTube video which is embedded into that. So this is an analogy for the 3D and holograms being embedded in other applications or platforms. So gaps and goals. So this topic aims to enrich the XR enables from 6G XR with third-party, ideally open source, and extensible interface. So this interface is what needs to be implemented and developed. And the form would be as a software library. It could be an SDK or some APIs to provide the possibility to easily embed the hologram in other VR, XR experiences. Examples, as I mentioned at the beginning, so I'm gonna end with these examples just to wrap up. So for example, a speaker as a hologram in a specific environment. So we can see this in many different use cases. When you have a speaker, it could be some events, virtual events. It could be in the education. Many examples I expect you can also imagine your side, that you have a speaker and some environments. Or, for example, very similar presenter as a hologram showcasing custom 3D content. So you can imagine that any 3D applications that are showcasing some 3D objects, it could be e-shops, it could be all these kind of things. You can suddenly spawn them a presenter, and this is very interesting use cases. And last example here, for example, integration of hologram to an existing XR platforms. So you can imagine a platform like Decentraland, for example, or others. This is just, of course, just an example. If it's possible, then integration with these platforms would be easier. So that's all for this holographics API.
Thank you, Matis. Thanks, Maria. Thanks, Matsuko. We move on to the next one, to Amr Abdelnabi from I2CAD. Amr?
Yes, hi. Yes. Hi, everyone. I'm Amr from I2CAD. I will be talking about on the Camara quality of demand implementation. As you know, that XR applications demand stable latency or some throughput from the network. This can cause a high uplink resource utilization that can lead to congestion in the uplink direction. The 5G network promised to expose some of the network capabilities through APIs, which is the new thing now. Then there is a Camara project that was developed as an open source project, which helps in defining and developing and testing of those APIs, which is appearing now in the figure. Like we have XR application function, and we have some service APIs. They are going to communicate with the network APIs, which communicate with the 5G core. This communication should be done through Camara. And one of the APIs that were developed there in Camara, which is the quality on demand API, that this application's function can request a stable latency or stable throughput. So we can use this in order to tune the parameters of the XR sessions according to the profiles of the users. But in order to do this, we need those service APIs to talk with the network APIs, and we need to establish those workflows. And this is the what we need to be developed and integrated and tested in order to have this connection between those service APIs and network APIs via Camara, based on those quality of demand profiles. And we are expecting as well to have a license that can be used and valid till end of the project, so that we are able to test and use those services. That's all from my side.
Thanks a lot. We move on to Roberto Viola from Vicomtech. Roberto, the floor is yours. 15 minutes, I would say,
Okay.
max.
Thank you,
have a lot.
Eleni.
You have a lot, thank you.
Yeah, for different topics, I'm going to discuss the following four. I am, first of all, I present myself. I'm Roberto Viola from Vicomtech. I am working package 3 leader concerning XR enablers. This working package goes most on, it's most about providing multimedia functions that are able to capture, process, and stream the volumetric video content. So this is a bit farther from the hardware, but it's more about providing a virtual network function on top of the edge computing. If we see the project, we have use cases concerning holographic communication. So we are already developing some VNF in order to deploy this use case at the end of the project. But with this four topic I'm going to present, maybe also the further one presented later by Mario, we aim also to try to provide new virtual function at our CGXR platform in order to improve these holographic communications. So if we go in order, of course, the first one is this capture system that we aim to improve in our test bed. So in order to have, of course, holographic communication, we need to have volumetric video sources in order to process them inside the network and provide this holographic communication between different users. What still we see as a limitation is that this holographic communication requires really expensive hardware, and it is not affordable by every users. So the idea with this first topic is to provide a new solution in order to provide volumetric video capture. We think the first aim is to provide, for example, solution with affordable devices and sensor in order to provide a wide range of users to access it. We can think about simple smartphone, we can think about Kinect and other type of solution. But in case of professional use cases, we can also think about more complex setup with multiple sensor and free viewpoint video capture. Another second problem about video capture is not just having this hardware and be able to capture the video, but also how to calibrate them. In most of cases, when we have a calibration, we need to provide a pattern that need to be recorded by the camera in order to adjust the internal process. We can think, for example, a checkerboard pattern that need to be capture and analyze with some algorithm in order to calibrate the camera. So this is complementary to the first thing that I say. We need to provide both an affordable devices and sensor in order to provide every user to access the holographic communication, but also to provide them a user-friendly calibration methods, because not every user can spend lots of time in order to calibrate their devices and sensors. Also, they don't even have the need to have like an expert level of knowledge in order to deploy these capture systems. We can go to the next one. The second topic, of course, after we capture the video, we need a way in order to compress and stream it. So the idea of this second topic that I'm presenting is about how we can compress this a great amount of data provided by volumetric video. If we think to legacy 2D video, there are lots of codecs that work fine with the current networks. But if we think about volumetric video or point cloud streaming, this is a really great amount of data, and there is still a lack of standardized encoder and codecs. Actually, some work is already done by MPEG working groups in their point cloud compression, but in real implementation are still limited. There are just some referenced solutions, but still far from being used for our real applications. So the idea of this second topic is to research and provide new proposals for this encoding and decoding problem of the volumetric video in order to be able to stream there in the current network. Because if we have too big amount of data, it's not even possible to stream there. So we need such in a way in order to compress it. Of course, the first and straight solution is to provide encoder and decoders, but we can think also are other type of solution, because we think in a virtual environment, we cannot see all the video in 30. You cannot see. We have not the need to see all the video. For example, what's behind me, I don't need this information. So we can think also other methods in order to provide a compression of this amount of data, such as pre-processing, apply viewpoints to the scene in order to view just to compress and send to the user only the amount of data that is actually in his viewpoint. So due to all these elements, here we can provide different solutions that are, of course, encoder and decoder, but also methods in order to scale these encoding solutions. It can be pre-processing of the video content in order to send just, for example, the viewpoint, or we can also think about subsampling a supersampling method. Instead of sending all the data, we subsample the content when sending it, and then supersample when it is received. And this is also another way in order to reduce the amount of data to be streamed. And of course, if some solution provided, it would be also interesting to investigate if there are some GPU acceleration possibility with the proposed solution. This is something optional, but it would be really interesting also to investigate these kind of solutions. And go to next one. This is kind of complementary with the previous one. When we compress the data, we need a way in order to send over the networks. So there exists already a lot of streaming protocols for the current 2D video, but the implementation for volumetric video are still limited. There are some adaptation of the protocols for 3D volumetric video, but there are still no widely uses. So moreover, another interesting thing to note is that not all applications have the same requirements in terms of latency and scalability. So actually here in the project, we are thinking about both scalability with adaptive protocols such as MPEG-Dash, but also latency. So typical solution are RTCP and WebRTC streaming. With this topic, we would like to go make a step forward in this sense, trying to adapt these typical protocol employed every day for 2D videos, and to adapt them with the newest protocol that will come later. So we are thinking, for example, to HTTP and quick protocols that some initial idea or implementation have been done for both Dash and WebRTC. And we would like with this topic to assess some real implementation or some proposal in this sense. On top of this protocol, also other possibilities are possible, not just to investigate how to integrate them with novel protocols like HTTP and Quick, but also how to use them in order to provide a better video stream adaptation. If we think about legacy video, here the adaptation is based on network performance, so depending on the network performance, you adapt the quality of the video to the network that you can have at any moment. In this case, the adaptation cannot be done just by the network capability, but it should be done also depending on the viewpoint of the viewers. If we send, for example, stream it to MPEG-Dash, we should be able to divide it into different tiles and send just the tiles that are necessary for the user to reconstruct the video. Here we can explore, for example, other things, not just the viewpoint, also the distance. Something that is closer can be sent with bigger resources. Something that is farther not necessarily need to be streamed at the same resolution or with the same quality. So here we think to work actually differently. One is to improve the current protocols with new solutions such as HTTP and Quick, but also on top of these protocols, also to provide new solution in order to adapt the video streaming to the actual situation of the user, which can vary over the time, can vary over the space, because it can adjust his viewpoint and the distance of what he's seeing in his scene. We can go to the next one. This is the last topic I'm going to present. This is a bit different from the previous one, from the other three that I already presented, which were about capture, compression, and streaming. This is more about assessing new metrics for VR and AR content. We have lots of methods, lots of metrics for typical 2D videos, such as bitrate, resolution, encoding, and so on. But all these metrics now are limited in order to describe what's the actual experience of the user in a 3D world, in a virtual world. So the idea with this topic is to improve our monitoring and telemetry system that we're going to deploy into 6G XR research infrastructure. We have, of course, lots of KPI and QoS metrics concerning the networks and also the typical legacy 2D video. But here is the idea to go further and provide new metrics that we can try to give, whose aim is to give us an estimation of how is the interaction of the users with the virtual scene. This metric should take care, of course, the quality of video, the quality of interaction, the quality of the audio, whatever aspect is interesting for the users in order to have a really good experience in the virtual world. In this sense, there are really, of course, direct experiment with users is always a solution, but it can be really time consuming to have to interview lots of people, what's their experience in the virtual world. So we aim to, in this case, we aim to have some more analytical approach and provide some solution in order to monitor metrics that can be like estimation of what's the actual experience of the users. And of course, there are generic metrics such as video and quality, interaction, motion capability that are provided, synchronization, and having a consistency in the scene that we are watching the virtual reality environment. But of course, depending on these cases, there can be new factors that depends of the specific use cases. So in this case, you are free to define what's use cases and how you mean to evaluate the experience of the user in these use cases that you have defined. And I think that's it from my side. We can skip to the next speakers, which should be Mario, and we will discuss more about other type of VNF media processing function that we are looking for with this open code.
Okay,
Thank you.
thank you, Roberto. Can you hear me?
Yes, Mario, please go ahead.
Perfect. So this is Mario Montagu from I2CAT, and I'm going to present 4 additional topics that mostly fit within the XR enablers category and complement the ones presented already by Matsuko and also from Roberto, okay? So yeah, Roberto has presented some topics related to capture of volumetric video content, encoding and streaming, and also potential topic is related to XR fusion, okay? So in the project, we are aiming to provide high quality, affordable, and interoperable holographic communication services. And for such a purpose, we are initially envisioning 2 types of multi-sensor capture subsystems. One are based on light field or plane optic sensors, those provided by Raytrix, which is a German SME, and they manufacture light field sensors. And the other one is using off-the-shelf sensors like Azure Kinect, okay? And other potential capture subsystems already described by Roberto are welcome in the project, such as those based on free viewpoint video or even mobile phones, okay? So you could capture an hologram using multiple mobile phones. So the goal of this topic 7 is to incorporate or integrate more advanced and potentially artificial assisted methods to fuse multiple XR streams coming from multiple sensors, okay? And the final goal is to provide a cleaner and higher fidelity reconstruction of holograms. We are focusing on holograms. If you think of this topic, this can be a broad thing, but we are focusing on holograms and ideally in real-time communications. So the idea is, for example, to provide, to clean the 3D reconstruction models, to complete missing points, because we can have data sets of how human bodies look like. So this kind of things. And in terms of format, we are addressing volumetric video formats. These are point clouds, or we can also work with color and depth maps, or also addressing newer or more emerging volumetric video formats like neural radiance fields, okay? These are all within the scope. There are just possibilities. These fusion methods need to be GPU friendly, and they could be deployed on the client side, but the ideal or the final goal is to offload the processing capabilities from the clients to the edge, okay? So that would be pretty much this topic. If we can go to the next slide. Okay, so yeah, we are encompassing multi-sensor capture setups for volumetric video, and this involve using multiple cameras, okay? And when you use multiple cameras, at the end, we end up with complex and sensible cable connectivity issues in our capture rooms, which not only affects in terms of aesthetics, but also in terms of complexity and agility of deployment, and thus higher costs, okay? And on the other hand, we are addressing multi-user holographic communication setups, which involve high processing needs. This means that we are using VR headsets, but the VR headsets are connected via cable to a laptop or a desktop PC with GPU capabilities, okay? So this brings, of course, inconvenience in terms of cost and in terms of mobility, okay? Or the freedom to move while you are immersed in the metaverse. So the topic or the goals of this potential topic would be to incorporate or to integrate functional prototypes, or ideally more advanced and TRL solutions with higher TRLs that can help us minimizing the usage of cables, okay? And this can be both at the capturing side, but also at the presentation side. For example, at the capture side, we know that there are dongles that provide some like USB to Wi-Fi connectivity, no, or HDMI to Wi-Fi connectivity. So the goal would be to move this to the 5G plus domain, okay? So that would be a camera with the output interface connected to a dongle, and this would allow making the volumetric video streams available to a processing server, and thus minimizing the use of cables. And the same thing for when using the headsets. We could have some wireless interface that could allow connecting processing stations on the edge to the or on the client side, but without having to connect via cable the headsets to a processing station, okay? Reference KPIs would be data rates at least higher than 100 megabits per second, ideally much higher, and latencies need to be ideally sub-millisecond, but at most a few milliseconds latency order, okay? If we can go to the next one. Okay, so in the project, we are encompassing rich human-to-human audiovisual interaction. This means person-to-person or multi-user interactions via holograms. But typically in social VR or XR or metaverse experiences, the users met there to conduct or to have any kind of experience, no? or even to conduct shared activities therein. So you could, for example, from the individual point of view, you could do things within the metaverse, like interacting with the virtual environment. But when you meet with others, you can conduct like gaming, collaboration, training, or teamwork activities, okay? So this is not provided in the project. So the gap and the goal is to enrich our XR enablers with third-party and ideally open source and extensible software libraries, SDKs, or APIs that allow us to provide multimodal interaction and collaboration tools and features, both from the point of view of single users, but also from the point of view of multi-user experiences, okay? Potential interaction interfaces could be those based on VR controllers, or those based on hand tracking, via voice or via gestures. There are just possibilities, but we are open to innovative and proposals in that domain. An example of features that could be provided is like, for example, a group of friends watching an educational clip or a football match together, each one from their home, okay, and being able to interact while watching the video content. Or in an educational context, to have a shared board and annotation tools to, for example, for a brainstorming or for an educational lesson. We could also have like co-design or co-creation tools, like having like 3D models that could be assembled collaboratively from multiple users, or also tools that allow some kind of gamification, education, or training activities, okay? There are just examples that could be within a scope in this topic. And we can go to the next slide, and this makes the last topic within the XR enablers category. Yeah, this is similar to the previous one. So the idea is not only to limit to human audiovisual interactions, but also metaverse experiences aim to recreate and stimulate multiple senses, okay? So like the senses of touch, olfactory effects, or for example, including ambient effects captured from real-world IoT sensors. So the goal of this topic is to incorporate new enablers that allow us to recreate multiple senses, okay? And that would need to be provided. That means in terms of software libraries, SDKs, APIs to provide such functionalities. Our strongest interest relies on haptic communications and feedbacks, but integration of other senses or ambient effects are also within scope, okay? And both low-cost solutions, such as those based on pressure or vibration-based hardware, or more advanced setups like haptic vests or gloves with force feedback are within scope. And if we can go to the next slide, which is the last one from my side. So just for reference, some preferences or KPIs for the last two topics are that open source and extensible enablers are preferred, no, are a plus for the potential applicants. Our VR projects are based on Unity and mostly Windows-based, so that would allow easier integration. Also, we look for compliant solutions with widely adopted VR headsets, like Oculus brands. Also, our preference is on more affordable and replicable solutions, rather than expensive or complex to replicate solutions. And we also aim for platform interoperability. This is quite complex in the VR or XR ecosystem, but for example, solutions that rely on using middlewares that are implemented on client side or on the edge are preferred, okay? In terms of latency, we're talking about interaction, multi-user interaction, so latency should be within some millisecond order or at most a few milliseconds. Also in the project, we are not addressing scalability, or we are not targeting higher scalable metaverse sessions, but at least the solution would need to support sessions with, for example, end users, and would need to be able to provide support for multiple sessions in parallel, okay? So not just focus for one single session. And yeah, these ends with the topics within the XR enablers category. These are just orientations, slight variations of these topics or more innovative solutions could fit. We have the feasibility check, so if you have any proposal, so please feel free to get in touch and we will be more than welcome to provide feedback. Thank you.
Thanks, Maria. Thanks a lot for the detailed presentations, everyone as well. Jussi, for the next one, Jussi Hapola, our coordinator on topic 15 from the University of Oulu.
Okay, yeah, so this final topic is a bit less constrained, and it's actually two topics in one. So the topic 15 on actually focuses on run enablers or sustainability enablers or both. So as I said previously, so we have run topics as in the scope of this project, and we are pursuing three different avenues. So on the run enabler side, the proposals can be following the 3GPP path. They can follow the ORAN path, or they can follow the disruptive path. A key thing to note in here is that the proposals, they need to be interesting and innovative, but also they need to be sufficiently mature run technologies that actually fall within the scope of our 6G XR South Node or North Node beyond state-of-the-art topics, which has been described in the Open Call info document. And also the proposals need to be something that can be integrated in at least one of the South Node or North Node research infrastructures. The second part is the sustainability enablers. So we are taking environmental sustainability as in under the spyglass in here. And sustainability enablers are really focusing on local green energy. So it is tied up with the energy measurement framework system that we are developing and trialing in this project. So it consists of controlling energy resources, charging or discharging of different elements, energy measurement and optimization solutions, and so forth. And for example, if we consider a topic that spans both, it would be, for example, the proposal of elements that use the network exposure function to enable control of the run resources based on the renewable energy resources we currently have and we have under prediction. So all in all, this topic 15 is intentionally a bit vague, and it's also intentionally a bit more open. So proposals are significantly more free-form, but definitely if you are proposing proposals under this category, you need to contact the relevant research infrastructure and really during the feasibility check to be able to verify that your topic is such thing that it really can be accepted for granting. So thank you.
Thanks, Jussi. Thanks. And on the next slide, we will be starting with the questions now. But before we start, I think you mentioned it, Jussi, but it's good to reiterate here that in the submission, you're obliged to pick one of the research infrastructures with the option, of course, to have either site in each node, but also both, but definitely to indicate for which kind of infrastructure your proposal is targeted. With this, I would like to, of course, thank all of our mentors / partners for the presentations. The aim was to provide more detailed information on top of what is already available on the website since Monday. Now the floor would go to the participants of the webinar. As mentioned in the beginning, you can use the chat for any questions. I think we had already a question on the slides, and yes, the recording, so the session is recorded, and the slides will be available on the website under the Open Call subpage. And you can either raise your hand and take the floor, or use the chat for any questions directly right now. You have the opportunity either on the call or on the more, let's say, technical side of the topics. And in case you could not, of course, attend today, but you have questions, you can always reach us at the email address that you see on the screen right now, both for any type of question, either on the research infrastructures or on the specific topics. We encourage you to reach out and clarify before developing a proposal that does not fit the requirements or the availability and the possibilities of the infrastructure, or does not fall specifically into the scope of the topic. So, of course, we're very much welcoming you to reach out. Would there be any question right away now? Otherwise, I see a raised hand. Jonathan, please.
Yeah, thank you.
Yeah,
thank you. This is Jonathan from Tenno. I have, I mean, I think more questions I will ask later on, maybe perhaps via email on the person who presented. But a quick question that came to my mind when topic 2 and topic 4 were discussed regarding the age discovery in the camera is, it was directly referred there to use a NEF, and 3GPP also developed age up specifications that provide enablers for age discovery or other things. So do the camera only consider the NEF exposure only, or is the proposal to use all 3GPP enablers, including age up, and to give more a wraparound solution, or is it directly to use only the NEF and for the camera project to directly use the APIs, define the APIs based on that? So could you give a bit of clarification on that aspect, both topic 2 and topic 4? I think both are related to camera and API exposure, so I wanted a clarification in these points. Thank you.
Thanks, Jonathan. Christina and Amr, any comments on that?
Yeah, well, we will start maybe with the where we are interested with what Camara can offer, because this is what we are working on now. We know that the NEF is offering a huge library, but let's just try to focus first on Camara and the quality of demand API that is already there in Camara, and try to make use of it. So yeah, this is I think answers what the question is.
Yes, Jonathan, I see you re-raised the hand.
Sorry, thanks, Amr, for the clarification. So a bit more maybe to clarify the question. My question is, when we develop, so when the proposal is to develop to enrich this camera, is the aim to use directly only the NEF, or also to use other 3GPP solutions, such as, for example, 3GPP Age Up, which is also do a little bit more on top of the NEF. So basically, its camera runs on top of 3GPP, and this Age Up is part of the SS6, which is basically part of the 3GPP still. So the idea is, when we develop these APIs, are we restricted to only the NEF part, or the idea to use the whole 3GPP solution? So on that, my question was on specifically on that part. Thank you.
If you don't mind, Eleni, Christina, I think he has to drop. I'm one of the mentors of the TOF to the Edge API, so I can try to address the Jonathan question. So that's a very interesting and relevant question. The suggestion of using NEF and 3GPP NEF is due to the current setup that we have on the South Node, where most of the camera activities are going to happen. This is why we close it for the time being for the 3GPP NEF, based on what we have right now on our 5G core to be evolved to the CG. Now, we are open to suggestion if you think that it can be implemented in a more efficient way using some of those 3GPP. It's something that we can consider. It will really require, we need to understand which will be either the impact on our current infrastructure. It doesn't mean that we are going to discard it. Maybe what I will suggest in those cases to make a proposal based on how do you will make it based on the NEF, and which could be the evolution with other 3GPP infrastructure APIs or infrastructure capabilities. It could be considered for an evolution, part of the evolution path of the infrastructure. So we are open to hear, but just be aware that for the time being, our capabilities are focused more on the NEF rather than the whole elements from that the 3GPP may offer. Hopefully this clarifies.
Thanks a lot. This clarifies.
Thank you.
Thanks a lot, Los. I'm looking at the chat. I haven't seen any other question unless there are more hands raised. It was also a lot of information. I understand that it's a lot to digest, and I'm sure there might be questions throughout the call. The call is open until the 27th of November. And you have also the address, the email address here, where you can address questions regarding the call or the topics in general, or the conditions for the implementation. Either we have been very clear or not. I don't see any more hands raised. Since we have a little bit of time reserved, I'm not sure if whether the partners would like to add something that was not mentioned already, although I think it was quite detailed in terms of the presentations. Otherwise, we would be very happy, of course, to stay in touch with the potential applicants. And if there are no questions, I think we can wrap this up. Yusi, would you like to?
Yeah, I just final thing as I really want to emphasize is that before making the final submission, contact us, contact the relevant facility, and make sure that whatever you're proposing is possible. Is something that will end up in passing the feasibility check and will end up to the evaluation status.
Definitely, yes. And also, as a side note as well, I mean, in terms of the opportunities, we will have to see also for the implementation. We're very keen also to, and this should be actually, it's in the guidelines in the proposal template, to dedicate some of the budget planning for traveling to the sites and getting in touch directly with the mentors. I think this is a very big opportunity and much needed based on each experiment and proposal. We will be in touch with all applicants within 1 month of the closure of the deadline. I think that that would be it for today. Thanks a lot to everyone for attending and for the presentation. And we look forward to receiving your proposals.
Yes, thank you very much.
Thank you. Bye bye.
Very much. Bye.
Bye bye.
Thank you very much. Bye bye.
Bye.